Hi guys. Today I participated in this Starters 138 and was able to solve 5 questions. Today and after the contest, I tried solving the sixth, that is easy mode. So I will be explaining you the first six problems of this contest. So let's go with the first one, distinct substring. So what the problem says. It is like a binary string is a string consisting of zeros and ones, and we define an island as a substring consisting of all zeros, either bounded by ones or by the ends of the string. What does it mean? Like you can see in this example, these zeros are bound by this one and this one, right? So this whole part is an island, and this part is also an island as because of this one and this the another side of this island is bounded by the end of the string, right? So either of the ends can be a string, or either end of the string can be a boundary of that island, right? So any zeros in between them will be considered as an island, right? So what we are given? We are given a string length and k. So what you need to find whether it is possible to form k islands with the condition that all the islands must have different length, right? So in such a way, whether k islands can be formed or not with the help of a binary string of length n. So you can place a zero or a one wherever you want. So how to approach this problem? So let's go with length one. So for one length island, how much length do we need? We only need a zero, right? For two length, like for two islands, what should be the minimum n? So for one island, we need one zero, and after that, I will need a boundary that is a one. And then after a minimum length is demanded, so we will go for two zeros, right? So this forms one island, this zero forms one island, and these two zeros forms another island. So we have two islands. Let's see for three islands how much needed. So for three islands, we will simply add one more boundary, and then since all the islands must have different length and we have lengths of 1 and 2 already there, so we will go for three lengths. So what is the length of the minimum length? What is the minimum length string from which k islands can be formed of different lengths? So this is 3 plus 1, 4 plus 4, 8. So for 2, it was needed up till here only. So it was for 2, it was 4 length string, and for 3, it is 8 length string, right? So, and for 1, it is like 1 length substring, right? This is length. Okay. So, what do we observe? Like for like here you see for one we can take one, but for two, what we are adding? We are adding one boundary, and then we are adding in the previous answer we are adding one boundary and the current length, right? So what it is? It is one plus like whatever is the answer. Like if we try to store it in our DP, then it is 1 plus dp of I plus 1, I minus 1. Sorry for that I am using a cursor right now. So that's why it's a little bit. I can explain it with the code only, and then it will be get clear. So this is the way we calculate it. 1 plus dp of I minus 1 plus I. Right. Since let's say we want to calculate for n equals to 4, then for n equals to 3, we already have this much length, and what you need to add, like one boundary, and after that four zeros, right? So this one is for this one boundary. This dpi minus 1 gives this length, right? And then I, that is I number of zeros. So this gives the answer. So here is my code. If I show you, so it's a pretty easy question. As you can see, what I have done, I have calculated it beforehand, and like before going through the test cases, and then you only need to take n and k. I have stored it in result vector, right? So if result of k, like what is result of k? The minimum length of the string that is needed to form k number of islands with that condition. Right, so if that is less than or equals to n, then we can, yes, we can form k number of islands with different lengths, or it is impossible. So yeah, let's go for the second one. So this one was also a pretty easy one, like the average speed of the car. Just have to go through the formula they have applied here, and since they are asking for like the minimum number of additional integers required. So what I did, I tried a binary search over this. So quickly, if I explain you, then this formula is basically what we are needing, what we are uh, calculating for. So this is the total distance, that is 500. We have traveled up till now, and this is the next uh, next hour, like how many hours we have added it into. So that is given here. So that we are adding in the base. So what our formula is basically about, uh, I have written it somewhere. Let me see. Uh, yeah, so basically in 10 hours, if we have gone through the distance, we have gone with the speed x, then in 10, can I insert, can I insert some text here? Okay, my phone. Okay, let me explain you quickly, like what will be the distance traveled in 10 hours if we are, it will be 10x, right? So this 10x plus, like let's say in the hundredth of second, what we are given here. Let me explain you through the summation only. So this is basically how we are calculating it. Ignore the all of the above codes. I have saved it as a template. So I used a binary search here with the minimum value as 0 and maximum value as 1e9. That is basically 10 to the power 9. And this is the total distance. And this one is the answer. I have initialized it with the maximum value. And for every step, we are calculating this mid. This is classical binary search approach. And what is the new average? So this new average is distance into 100, distance plus 100 into mid. This mid is like what the answer will be, and divided by 10 plus mid, because we have traveled for 10 hours, and then again with 100 kilometers per hour of a speed, we can travel mid number of hours, right? So this gives us the total new distance, and this gives the total new time. So dividing this will give our new average. So I have taken it into double. You can also go for int. So if this new average is greater than equals to y, right? That's what we need. No? Like we need the minimum time in which we can go for this y average. So if that new average is greater than or equals to y, since it is double, new average is in double, so that's why I have multiplied it with 1.0 so as to not mismatch the types, right? So if that condition satisfies, then set your answer as mid and go for the lower values, or else go for the higher values, and at the end print your answer. So that's it for the second one. Let's go for the third one. This was pretty interesting. Like it took me around 15 to 20 minutes to solve this one. So what this person is basically saying that you are given an odd integer n, right? Uh, this n is odd, and you have to form an array A of length n satisfying these two conditions that all the prefix should have a bitwise end greater than or equals to bitwise, or like the resultant end of the prefix should be greater than or equals to the resultant or, and for all the suffixes the end should be less than or equals to the bitwise XOR, right? So let's try to understand what this problem is saying. So for the prefix, what I thought was like let's take um, like let's take some number x, like let's say 3, and again 3. So for the prefix, it will be like since the number n is odd, let's try to go for like n equals to 2. That is not the case in the question, but let me try to explain what my idea was. So since 3 and 3 is there, so what will be their end? So their end will be 3, and what their XOR will be? Their XOR will be 0, right? So does this satisfy the prefix condition that the prefix end should be greater than or equals to the prefix XOR, right? So here the prefix end is greater than or equals to prefix XOR, right? But what about the suffix now? So that was the that was the main problem. So what I did, like what I did was this 3, 2, 1, right? So if you consider, so here also this 2 and 1 gives XOR 3, and this 3 and this 3 will total give an XOR of 0, right? So let's mark XOR as X. So that XOR will be 0, and what will be end? End value will be 0 also. 0 only, right? You try to do 3, 2, 1 end, so it will give you 0. So what we see, like if we put in like this, so our prefix condition is satisfied. Let's see what about the suffix condition now. So the suffix condition end should be greater than end should be less than XOR, right? Yeah, end should be less than XOR. So are we doing so? Like 1 and 2, end is 0 and XOR is 3. So our end is less than XOR, right? And what if we go to this 3? So the end will be 0 and also XOR will be 0. So what if we have more number of 3s? So just if you have like, let's say this is for n equals to 3, right? So if you have n equals to 5, just add 2 more 3s here, right? Then also the condition will be satisfied because this part AND is also 3 and XOR is also 3, right? So that's what my that's what my idea was. Like if you have found any answer for n equals to 3, just expand the last integer or the first integer from the left side beyond this, right? So if you have n equals to 5, this one is the answer. If you have n equals to 7, just add two more threes in the beginning, like this. So that's what my approach was. Let me show you my submission. Come on, yeah. So basically for n equals to 1, I just printed 3. If the n is 1, you can print any number. And if the n is greater than 1, then just to go for the n minus 2 numbers, you print 3, and the last two numbers as 2 and the 1, like I showed you in the example here. So this will be the format. For n minus 2 times, you just print 3's, and rest of the times, for the last two digits, you print 2 and 1. And that's it. Let's go for the fourth one. So this problem was basically a pretty mathematical problem. So let's try to figure out what this question is saying. So you are given the range 2 to 10 to the power 18, right? And you have to figure out three integers. Like A is given, and you have to find these two integers B and C, which are consist like which are in increasing order, like A is the least, B is less than C, and C is less than 10 to the power 18, right? And what does this mean? Like what I thought was, if some number is x, right? So let's say you are given some x, and one more thing to notice is this A's maximum limit is up to 10 to the power 9, right? So if we take A square, like if some number A is given, and you take some another number A square, right? So in between them, if you take any number greater than 2, like let's say some x which is greater than 2, then definitely this a to the power x is divisible by this a square, right? If x is greater than 2, right? And similarly, what the second condition was, like this x to the power c, which is a square. So x to the power c, that is a square, must be divisible by a. So for this, what we need to do, like this x must be a multiple of a, right? Then only if you divide this base, no matter what the exponent is, it will definitely be divisible by this a, right? And this pair I considered with the constraint, like the age maximum limit is up to 10 to the power 9, and we are allowed to take numbers in the range 10 to the power 18, right? So I blindfoldedly pick up a square, like a to the power anything greater than 2 will be divisible by this a square, right? Like you think if x equals to 3, then a cube will be there, and a cube is definitely divisible by a square, right? So this 3 can be any integer greater than 2, but what about this case that x to the power a square must be divisible by a? So for this to be true, this x must be a multiple of a, right? So what is the least multiple we can have? So if a into 1 we take, that is not allowed, right? Because all the three integers must be distinct, a, b, and c, and also be in the increasing order. So what remains for the minimum? We have yes, a into 2, that is 2a, right? So this we assign to this x, right? So the first number will be if it is given a, then second number we can take 2a, and the third number we can take a square, right? So that's the main idea. Like now, if you see this 2a to the power a square is definitely divisible by a because 2a, whatever the power we put on it, that is greater than 0, we will get a number which is divisible by a, right? Let's say 2a to the power something y. It is definitely divisible by a, right? So that's what my approach was. Uh, so with this, we have completed the fourth problem also. Let's go for the fifth one, which I think was comparatively easier than the fourth one. I found it, although I made a wrong submission in this due to lack of some observation, but later I corrected it. So let's go for this one. What does it say? Like Seth has been given an even integer, and mind this is an even integer, right? And you have to find three distinct integers a, b, c such that all are primes and the sum of their squares must be equal to n. So what does this indicate? Like if we try to observe it carefully, let's try to pick up some simple prime numbers. So this will be 2, 3, 5, 7, 11, and so on, right? So we have to pick three integers, three prime integers. Like this list will be continued. I am not gonna discuss further on that. So let's just try to pick any of the three except this two, right? For now, just forget this two. For now, just forget this two, and let's try to pick three among them. So let's try to pick up 3, 5, and 7. So what will be 3 square? It is 9. That is an odd integer. What is this 5 square? 5 square is 25, and similarly 7 square is 49. That will be three different odd integers, right? So we all know that sum of odd integers, odd times, will never be an even integer. So picking up three different odd primes can never give a even sum, right? But we have n as even, right? So what does this indicate? That these two must be picked, right? With two other odd integers. Like if we try to take these two, so these two, 3 and 5, with this 2, 2 square is 4, will give an even sum, right? Like two odds and one even will always give an even sum. So that's what the whole observation was based. Uh, so now all we need to check like what is the constraint on n. So since it is 10 to the power 10, I thought of first collecting all the primes that are less than equals to 10 to the power 5. Why 10 to the power 5? Because we are summing up all their squares, right? Not the original numbers. So we need to consider just all the primes that are less than or equals to 10 to the power 5. Okay. So now let's go and what after that? So we have already one among them. Like if we have A, B, C, three different primes, then we have already sorted one. This A is definitely be one of two, right? Now we are left with finding these two. So what the current n is now? This current n will be definitely n minus 4, right? Because we have already picked one of the primes, so that their sum must be subtracted from this n, right? So n becomes n minus 4 now, right? Now we are left with finding b and c. So what we will be doing, we will be first getting all the prime numbers in the range 3 till 10 to the power 5, and among them, what we will be trying to do, like we will take, like let's say we are on some prime number x, right? So we do the square, subtract from n. If it is if the x square is greater than n, we break the loop. We do the loop until only till x square is less than equals to n, right? Then only we can find the third number, right? This c. We are currently this x we are taking as b, right? So if the number is x, then we do a square and we subtract n. Remember this n is n minus 4, right? The new n is n minus 4. That's denoted by n dash. So this n dash minus x square. So what we are left with now, if this is a valid b, if this x is a valid b, thus the rest n double dash, what will be n double dash? N double dash will be n dash minus x square. So this n double dash will be, let's say, some y. So this y must also be a perfect square, and that too for a prime number, right? So this y is c squared, right? Now how do we check if it is a square root, if it is a perfect square of a prime number, right? So what we do, we find the square root of it. Let's say it is s that is c, and now we do s into s. So if that is equal to this c, if that is equal to this y, then yes, it is a perfect square. Now what I need to find, if this s is a prime number or not. So how I did it, let's go through the code. I did it when finding these prime numbers, I stored them in a vector. So let me just quickly walk you through the code. So here I calculated this p is basically marking whether a number is prime or not, up to 2 into 10 to the power 5, right? And this primes is storing all the prime numbers in that range, right? This is marking the prime numbers in the range, and this is storing all the prime numbers in that range, right? So since 0 and 1 are not prime numbers, initially I have marked all of them as prime numbers, right? This is the classical sieve of Eratosthenes. I will put the link in the description. You can go through it to like get this algorithm correctly. So since 0 and 1 are not prime numbers, I have initially marked them as zeros. And from 2 till 4e10. Why this 4e10? Because the n is like we are finding up till 1e5, right? I have taken 2e5, but we need to find all the prime numbers in the range 3 to 10 to the power 5. I have taken 2 times 10 to the power 5, right? So if your pi is 0, I am pushing it